So it's going on 98 more done. So we're going to look at radian measure. And remember, a radian is just the ratio of the arc length to the radius, right? And in geometry, we took a little wiki stick and we put it around the circle, remember, to see how many times it went around. So you kind of have an idea of what it is. We know that we're just going to label the quadrantal angles here. So here we are at 0 degrees. This is at 90 degrees, 180, 270, right? So as far as radian measure is concerned, here we're still at 0, because this is 0, it's also 360. If I go all the way around the circle, how many radians is that? All the way around. What's the distance around the circle if the radius is 1? How do you find, what is the distance around the circle in general? You've known since junior high, before that. What's it called? Circumference, right? So if your radius is 1, what's the distance all the way around the circle? 2 pi, okay? So this is 2 pi. So 360 degrees is 2 pi radians, right? So what's halfway around? How many radians? Pi. Okay, so this is pi. So 90 degrees would be how many radians? Right, but it has to all be in one fraction, always. What would it look like? Pi over 2. Okay, so what you have to learn, okay, because eventually you're going to have to just know your radian measures, right? Now, these aren't going to be that difficult, but there's lots of other ones in there you're going to need to know. Learn how to count around the circle. What I mean by that is, here we're basically, we start at 0. Then this is pi halves, right? So if I go 90 more, isn't that 2 pi halves? Like I've gone 2 of those? It doesn't 2 pi halves reduce to pi? Does that make sense? So this is 1 pi over 2. This is 2 pi over 2, which is really pi. So what's this? 3 pi over 2. And then this is 4 pi over 2, which is really 2 pi. Does that make sense? And if you can think of it that way, that can help you understand what they are and kind of count your way around quickly when you understand the pieces. Okay, we all good with that so far? Now, they don't all come easily where you can just like count them. If I have some obscure number like 63 degrees and I want to know how many radians that is. So we have a conversion factor. And all it is a proportion. So I want you to think about, we've got to look at the relationship of radians to degrees. So we're going to convert from from degrees to radians. So what I want is radians from my degrees. So I want to look at how they are related, a proportional type relationship. Well, I can pick any of these. I can pick 360 and 2 pi. I can pick 90 and pi over 2, or 180 and pi, or 270 and 3 pi over 2. What's the simplest relationship of these that we have written down up here, do you think? Would you say this one? Doesn't have any fractions, and it's less than this is right here. Does that make sense to you? So it's the same relationship in all of them. That one just comes out the nicest. So I know when I'm looking at a radians to degrees relationship, the radians here would be pi. So for every pi radians, there's 180 degrees. Does that make sense to you? So what I want out of this is I want radians. Mathematically, what do I do to get radians by itself? Multiply both sides by what? Degrees, right? Okay, got to get that out of the denominator. So that means that radians is going to be equal to pi over 180 times the degree measure. Every single time. You don't have to set up that proportion every single time. I just want you to see where it comes from. So when I'm going from degrees to radians, what I want is radians. I just take the degree measure I have and multiply it by pi over 180. See how easy that is? Everybody okay with that? Every time, it's an easy conversion. So if I took 90 and multiplied it by pi over 180, that gives me 90 over 180, which is pi over 2. Make sense? I didn't have to do that to get that one because I could reason my way around. Same thing, if I put 270 and multiply it by pi over 180, I'm going to get 270 pi over 180, which is going to reduce to 3 pi over 2. So if I have some obscure number, I can stick in there and it's no big deal. So what if I'm going from radians to degrees? So I got to see how the degrees relate to the radians. Well, again, I'm going to use this. It's just the other way around because degrees are on top. And this time I want to get degrees by itself. So what do I do to get degrees by itself? Multiply by the radians. So the degrees that I need is just equal to 180 over pi times the radians. So when I want to convert from radians to degrees, just multiply the radians by 180 over pi. So it's either 180 over pi or pi over 180. It's as easy as that. And so you just got to decide, am I trying to divide the pi out of it, or am I trying to put the pi into it? Figure it out either way. Easy enough? You want to not always have to convert if there's special angles, and that's one of the things that we're going to look at tomorrow. And we're going to look at that a little bit today when we graph, but you also have to know just how to straight up convert so that when when it's not something that you can reason around, that you can get to it. So we want to convert each degree measure to a radian measure and give the quadrant. So we can give the quadrant first, right? If it's a 60-degree angle, what quadrant's it in? 1. So we're in quadrant 1. So I'm going to take 60. I'm supposed to multiply it by, is it pi over 180 or 180 over pi? If I'm going from degrees to radians. Pi over 180. If you're going from degrees to radians, the radians have to be in the numerator. So it's pi over 180. Then, without a calculator, you got to be able to handle this. Y'all can handle this. Think smarter, not harder. I can knock those zeros out, right? Can I still reduce before I multiply? Yes, if that throws you off a little bit and it helps you to actually write it, I mean, you can. But how many times does 6 go into 18? 3. So is my answer 3 pi? What? No, what's my answer? Pi over 3. So 60 degrees is pi thirds radians. Okay. Does that make sense to you? We good? All right. So then 105. What quadrant is that in? Second quadrant, right? Because you would go up to 90 and then a little bit more. So I'm going to have 105 times pi over 180. And then this time I don't have any zeros to knock out, right? Are they both divisible by 5? Yeah. How many times does 5 go into 105? 221, right? And how many times does 5 go into 180? 3 times into 18, right? With 3 left over. And then 5 goes into 36 times, right? So this is going to give me 21 pi over 36. Can I reduce that some more? Yep. What are they both divisible by? 3. So this gives me 7 pi over 12. So 105 degrees is 7 pi 12ths radians. Everybody okay with all that? All right, do that last one on your own if you haven't already. All right, so which quadrant is this in? First quadrant, right? Because it's negative, so I'm going clockwise. So it's in quadrant 1. And so I'm going to take a negative 330, multiply it by pi over 180. So put that over 1. You can knock out those zeros. These are both divisible by what? 3. So this gives me negative 11 pi over 6. Can I reduce that anymore? Nope. That's it. All right. Any questions about that? All right. So the next one, before we start converting, we're going to do the quadrant first, and I want you to We're also going to graph it. I know it doesn't say to do that. You can graph it first, last, whatever, but we're going to graph it first because that'll give us our quadrant, and then we'll go ahead and convert. But we're going to think about what's happening before we actually start converting or graphing or whatever, because we have to start thinking radians. In calculus, you don't talk about degrees at all. Everything is in radians. So when I'm up here, I'm going to go back up to my unit circle up there. So I know that what I want to figure out is where 7 pi fourths is, right? Well, I know that this is 0, this is pi halves, this is pi, 3 pi over 2. So where would pi fourths be? Just pi fourths. Which quadrant? Pi over 4. First quadrant, right? Do I know about where it would be? Halfway, right? So pi fourths is how many degrees? 45. It's got to be, right? So remember how I said you got to learn how to count around the circle? So if I get to here, and this is pi fourths, right? Because it's half of pi halves. That makes sense, right? So pi fourths, this is 2 pi fourths. What would I be right here? 3 pi fourths. If I want another 45, I go another 45. I'm 4 pi fourths, and that's pi. That makes sense, right? And then this would be what? 5 pi fourths. I go another one. This is 6 pi fourths. Isn't that the same as 3 pi over 2? Okay, so then 7 pi fourths is right there. Does that make sense to you? So without converting at all, I kind of converted. I mean, I think I could figure out what the answer is even without doing my fancy conversion here, and I can graph my angle. So when I'm here, remember that you always start with one ray on the positive x-axis. Then the other one, it's not a guess. I know it's halfway. It's okay if it doesn't look perfect, though, because we're not going to actually measure. But it's right there. This is my angle. So before I even actually converted, and I know you don't have a great concept of where the radians fall just yet, but you will if you learn how to think about what's happening around that circle. So I know then, just by doing that and thinking about what my measurements are, that this is in quadrant 4. Okay? So I can convert one of two ways. I know it's halfway between 270 and 360, so I can just take 360 and subtract 45. That is okay. But if you didn't just know that, or if it was something a little bit more obscure, you got to be able to do the math too. So 7 pi over 4, what would I multiply that by? If I'm going from radians to degrees. What's my conversion? 180 over pi, because I want to divide the pi out, right? So 180 over pi. So when I do that, my pi's cancel out, right? And I can reduce before I multiply. If you're scared of fractions, you got to get over that. Hopefully Algebra 2 got you over that fear. But so I know 180 divided by 2 is 90. If I divide that by a 2 again, what do I get? 45. So 4 goes into 4 once, goes into 180 45 times. So now my denominator is gone. All I'm really doing is 7 times 45. So do that in pieces. What's 7 times 40? 28. So it's 28, so it's 280, right? And then 7 times 5 is 35. And together that gives you 315 degrees. Which, because we kind of understood how the radians worked, that's the same as 360 minus 45 if we knew how much that was there. Okay, everybody okay with that? All right. So I want you to look at B, and I want you to see if you can get B graphed before you convert or anything else. So we look at our denominator so that we can count, right? And we know 90 is how much? Pi over 2, right? And this is negative. So I'm starting here. If I go to here, that's negative pi over 2, right? Another 90 is negative 2 pi over 2. And then one more is negative 3 pi over 2. So it's right there. Everybody okay with that? Does that make sense? Think your way around it that way? Okay, so what quadrant is it in? It's quadrantal. Good. It is a quadrantal angle, and it's on the positive y-axis. So by doing that, do I really even have to do the conversion? No, it's what? Negative 270. Okay. Still got to be able to do the math though, so all of them didn't necessarily need to be super easy to just count, because some of them you're not going to be able to do it that way when you just straight up convert, so you want to make sure that you know what to do. So times 180 over pi, just not real. I don't know very well yet how well y'all are handling fractions and stuff, so I can reduce the 2 and the 180, so that's really just negative 3 times 9. That's where your negative 270 comes from, but again, you already knew that, so just a good way to check yourself. Oh, times 90, thank you, though. Thank you. All right, we all good? So let's think about this one. Got pi 12ths, right? Well, I know that first of all I got to start here. Can you tell me at least what quadrant it's in? First, it's got to be, right? Because it's less than the pi halves. So this right here is at pi halves. If I go to here, this is pi fourths, right? If I cut that in half again, I get pi eighths. I don't get pi 12ths. What would I have to multiply pi fourths by to get pi 12ths? 1/3, right? So if this is pi fourths, well, this would be times 1/6 if I did pi halves, but I was already here at pi fourths. So I need to divide this in 3. Does that make sense to you? So if I divide that in thirds, it would be like here and then here, right? So there's my 1, 2, my thirds. So my angle would look something like this, even if I don't know exactly what the measurement would be yet. Okay, does that make sense to you? Do you see how you can reason around it? So if I have pi 12ths, and that should hopefully let you decide what the actual measurement is too, but we'll go ahead and do this. So my pi's cancel out. Then I got to decide how many times does 12 go into 180? Does it divide evenly? If you're not sure, you can always divide it a little bit at a time. I know that they're both divisible by 2, so this gives me 90 over 6. That gives me 45 over 3. And then can I reduce again? What do I get? 15. If you get some numbers that you're not real comfortable with, you don't have to always think about the biggest one and try to actually divide. Just take it as a fraction, reduce a little bit at a time until it gets down to something that you're more comfortable with, so that you don't do weird things and miss easy questions because you didn't reduce a fraction correctly. We all good? So you got to be able to convert in both directions, whether it's something that comes out nicely or not, and be able to graph them, understand what quadrant they're in, that sort of thing. And if you think about how they're related to the quadrantal angles, that should kind of help you with your reasoning right now. Okay. Remember, on the inside of the notes, I don't want you filling anything else out yet because there's a whole process that we're going to talk about in there to kind of help things, so just kind of ignore that. I wouldn't glue this in yet. You can, but it's going to make it easier to write on if it's not glued in, and you just hang on to it until tomorrow. Okay? We good? Any questions at all? All righty.